My name is Sharon Koch from Manure Manager Magazine. To start off, I'm going to do some housekeeping. Anyone who has signed up for the webinar will receive an email with the link of the webinar so you can view it at your leisure. Anyone viewing this webinar who has questions, the questions can be added to the GoToWebinar question panel. If there are questions that are not answered, John and Chris will follow up with you personally following the webinar. I am happy to introduce John Mishler, Tactical Marketing Manager, Precision Ag Technology at John Deere.
Thank you, Sharon, and I want to begin by saying what an honor it is to be with all of you today, and thank you for this opportunity to share a bit more information about HarvestLab 3000, our sensor technology, coupled with Manure Constituent Sensing. With me today is Chris Arnold, the product manager. Chris, why don't you share just a little bit about yourself with us?
Thanks, John. I'm a product marketing manager for our field and crop sensing technologies here at John Deere ISG, which is our precision ag division of John Deere. I work with our different types of technologies for nutrient analysis, soil moisture analysis, rate control, those type of products. My background is in agronomy. I'm an agronomist by training, had a career in crop consulting, farm management, and then a number of years in the irrigation industry. So I definitely bring a perspective of application of our technologies on a grower level. So the nutrient side of with the HarvestLab is very much fits into that kind of expertise and experience.
Excellent. Thanks, Chris. I appreciate that. And my role with Deere really is one around making sure that we're well informing customers, potential customers of the product offerings and sharing the value that these products deliver. So with that being said, you know a little bit about us. Let's learn some more about HarvestLab 3000 Manure Constituent Sensing. So let's go ahead and roll the video and get going. Today we're here talking with those in attendance about our manure sensing technology. This is brand new technology that we just recently introduced to the market. It's really all about being able to accurately, confidently apply and document the nutrients in liquid manure. John Deere's really been on this journey to help customers really connect better with those that help them make decisions in their operations. Farmers don't farm alone today. So being able to actually document what nutrients are applied on a field and exactly where they're applied and at what rate is really critical to the next operations that take place on that field. So when we think about that, being able to get that data collected off of a display and into a cloud application like John Deere Operations Center, that farmer's really in control of his data. He makes the decision about with whom he shares that information, who can actually see it, and help him then make additional decisions about the field. You might be able to imagine, for example, being able to share that information with an agronomist who's going to look at that and then make variable rate application recommendations that then can be later executed back on the field with variable rate technology, additional technology that's available through John Deere. So it's important that our solutions retrofit onto the equipment that customers have today, for example, be it a tanker or a dragline application system. This sensor mounts on that application equipment and it measures the nitrogen, ammonia nitrogen, phosphorus and potassium levels at 4,000 times per second. It knows the flow rate being applied based upon a flow meter on the application equipment, and then actually calculates in real time the rate per acre being applied. What's more is if you're actually using a John Deere tractor, we have tractor implement automation. So in conjunction with the rates being applied, we can vary speed of the tractor. As an example, if you were wanting to apply 200 pounds of nitrogen per acre, you can set that in our precision ag display. And tractor speed will adjust to hit that rate. On the other hand, if you're concerned about not over applying a nutrient, such as potassium, you can also set that rate as a limit. And the tractor speed again will automatically adjust based upon the nutrient content being applied at that moment in time to limit no more than that application. The other thing that we also think about though is, do we have the ability then to also work on competitive brands, non-Deere tractors? The answer is actually yes. We have our 4640 universal display. It's a Gen 4 display, really a display all about usability, performance, and choice that can be retrofitted into other brands of equipment along with our Starfire receiver technology and actually give that John Deere Precision Ag experience to non-John Deere branded equipment. The sensor itself has been a tool that we've had in our offering for a number of years. It's been first used in self-propelled forage harvesters to actually measure moisture content during silage harvest. Then that same sensor can be used in this format with a turntable so that those farmers that are feeding silage can actually monitor quality of silage being fed on a daily basis. No longer do they have to send silage samples off to a lab. They can actually do that analysis in real time as they're preparing to feed and do any ration adjustment that they need to do. And then, as I mentioned earlier, right, manure sensing. That's the third application for this same near-infrared sensor technology that allows growers to confidently apply liquid manure at the right rate in the right place.
Okay, thank you. We have some questions. The first one is, how is the third-party verification going of this technology in the U.S.?
Good question. So the curves that we're running were initially developed in our European division. We spent a year and a half taking those curves and running them with cooperators and gathering samples, and we ran those through the University of Wisconsin. They did the verification on the manure samples versus our calibration curves, and that verified that the curves that we initially started with would work over here as well. We're continuing to do that. We're focusing in on areas of the curve where we want more samples to get more accuracy, and then over the course of doing samples, we add that to that database that makes the curves even better.
Great. How are the reports stored?
So I'll take that. This is John. I'll take that. So the data from HarvestLab 3000 and Manure Constituent Sensing ends up in our cloud-based system, John Deere Operations Center. So the data there gets to Operations Center either one by JD Link Connect, depending on a given farmer's situation, but JD Link Connect provides the opportunity to wirelessly send that data to the cloud device and store that data as applied data in the cloud, making it such that it can be easily shared with those that help farmers make decisions. Another way that that data can get there is through a thumb drive, a USB drive, and uploaded from a computer system, a laptop or desktop computer over the internet to Operations Center, to John Deere Operations Center. So it's stored in that cloud service, John Deere Operations Center.
Next question is, do I need to have Wi-Fi for this?
So again, Wi-Fi would be not necessarily required, but we think about, because just in the scenario that I explained, we tend to use a cellular connection to the tractor with our mobile telematics gateway, MTG technology on a machine. And in the situations where that connectivity via cellular does not exist, it can be done with a thumb drive and uploaded that way.
Can you get reports of nutrient levels applied in each field?
Yes, you can. And we can document up to 4 different aspects of the data collection that we're doing. So you can select which 4 layers that you want to document and upload to the Operations Center.
How does the sensor measure nitrogen?
So the sensor is a near-infrared technology, so it's utilizing a light source, and we're measuring the reflectance back on that, and that data that we get back is called spectra, and that is then run through the calibration curves that we created, where we compare the spectra readings versus wet chemistry on the samples when the curves are created and validated. So it's a correlation value from what chemistry, like sending a sample to a lab, would give you. And so it gives you that correlation trend of the manure as it's flowing past the sensor.
So I'm not nearly as technical, Chris, as you are, but here's how I think about it. You tell me if I'm right or wrong, but I tend to think about it. So the sensor is measuring the light reflected, and it's really comparing that to known values from all of the validation and testing that's been done, and says this matches that, therefore this is the percentage of that nutrient in this sample at this moment in time.
Yes, that's correct.
Okay.
So it like I said, it's a correlation value, so it won't match exactly, but it's as the sample base gets deeper and deeper, then we get more tighter to that correlation.
Yeah.
And that's what our goal is, to have enough values in there to get a good curve to start with, and then over time that curve gets actually better. It's the same principle we run on the forages that we've done with this same sensor and it's been out for 8-10 years now. Those curves are getting much tighter because we have that many more samples that we compare against every year.
Right.
Where can we find out that verification done by the University of Wisconsin?
That's not it wasn't a published trial. It's basically, we contracted with them to do validation work on our curves.
Is the product available now? Is there information available in the sales manual?
Yes, it's been released since the first part of August. We did a soft launch in June to start promoting the concept and the product. In August, it was available for order, and there are systems out running right now.
So has there been any issues with calibration if you used like non-John Deere machines?
No, because the calibration is in the sensor itself. So this technology can be used on non-Deere equipment. All the application equipment is basically non-Deere. We've created a mounting system that goes on tankers or drag lines. We've got systems that are running on other brands of tractors that are pulling those tankers and drag lines, but it utilizes our John Deere technology with our display, our 4640 universal display. Oftentimes they'll add, if they don't have the MTG or some connectivity, they'll add our MTG to it as well to get that connectivity.
Yeah, so the real key there is, if we're talking about non-John Deere equipment or a non-John Deere tractor pulling application equipment, the display technology, receiver technology still needs to be John Deere Precision Ag display receiver technology to enable the solution.
Yes, that's correct.
Yeah.
So do you still need to send a sample to the lab for this to be accurate?
So you can send samples to, if you want to get a correlation between the lab that you're utilizing and what the sensor is reading, that can be done. But the key is to get the same sample that you're comparing to the display. You don't pull a sample out of the storage lagoon and then go out and apply and then just take a reading off the tractor to see if they're the same. You need to actually pull a sample out on the rig when it's running and capture a screenshot of the display to see what that sample was showing right then, and then send it into the lab and get an analysis. The thing to be aware of is every lab has different processes and procedures. There can be variability in the results getting back from different labs. Even within a lab, you can see variability from time to time of who's running the samples. So just be conscious of it. So at one point in time that you're looking at it at one sample versus as you're applying it, the sensor is actually looking at that sample 4,000 times a second to get a reading on it. So you will see some variability there, but it should correlate to be fairly close.
Well, so there sounds like there's two pieces of variability going on in that equation. So there's the actual variability of the manure itself. I pulled a sample from the tank or from the pit, the storage facility, And in comparing that to what the sensor is saying we're applying now, well, the sensor is going to read whatever's running by that sensor at that moment in time across the field. That could change across the field.
Yes,
And then the other piece of variability would be just lab result variability or potential human error in reporting results.
right, that's correct. So as the lagoon or pit's being pumped out, you're going to have variability there depending on the degree of agitation. We've seen pits vary with temperature and then also vary from facility to facility based on what kind of livestock it's coming from. So in a hog operation, you can see variability from a farrowing barn to a finishing barn. So those values will vary across those different locations as well as the species of manure as well. So that's why there's a swine curve and there's a cattle curve for the two different types of species manures as well.
Next question, can the reports, what's been applied where, be printed out and shared with the farmer?
I'm going to have to follow up on this one. Do you know off the top of your head whether the printout ability from, it does exist. I'm confident that it does exist. So report format from John Deere Operations Center does provide the ability to print those as applied reports that can be shared then with a farmer. The other thing that I'd mention here too is just that whole sharing principle. So using John Deere Operations Center becomes actually quite easy to share that data without having to print it out. We have the ability within Operations Center to, the grower does to, or the farmer, or in this case, I assume the custom applicator, has the opportunity to actually set up sharing permissions of the data in and of itself directly with a customer or a farmer, and actually eliminate the whole need of printing and sending reports if you choose to do that or want to do that.
In addition to that, then you can share that same data to a third-party agronomist or fertilizer company if you're wanting to create prescriptions for the next phase of the application, because now you have the ability to apply that manure at a consistent nutrient rate for whichever nutrient you select. So say, for example, nitrogen, you can have a consistent nitrogen application, and then you can send that data to the third party, and they can look at what needs to be added to that field to meet the crop needs for the coming year. The other way to look at it too is if you're applying strictly by gallons and that nitrogen and phosphate rates are varying across the field based on the variability of the manure, you do have an as-applied map in that instance as well, which you can then create prescriptions based on that. So if you got variability in the nutrient application, you can create a variable rate prescription then to meet the requirements that you need for the crop.
Next question, do you need to tell the system which manure you are applying?
Yes, you select either swine or cattle.
Okay. Could we get the ability to use a cart of equipment? Configure as example, we have 2 liquid trailers at the back of the tractor and we don't have access to the cart on the configuring menu of the manure rate.
I'm not quite following the question here. If you're running dual tanks and you're pulling out of both of them and it's passing by the sensor, you'll have an as-applied map for both. If the second tank is just directly applying and isn't going by the sensor, then in that case you would not have the ability to get an as-applied map because you wouldn't be passing by the sensor. But as long as the manure flow is going by the sensor, you will get an as-applied map.
Is the sensor measuring only total nitrogen, or will it measure organic nitrogen and ammonia N as well?
Yes, we read it out as total nitrogen and ammonia nitrogen both. So your ammonia nitrogen is your readily available form, which is available for crop right away, or in some cases, to think about it, it's also what is leachable or could be lost. The organic portion If you take the total nitrogen and subtract the ammonia portion, is that organic portion that's going to break down over time. So everybody's aware that when you spread manure that you're always going to get some residual benefits that second and third year. That's that portion of the total nitrogen that's left over after we subtract out ammonia.
What is an estimated cost range for a unit?
So cost of the solution can certainly vary between depending upon installation, what perhaps a customer may already own, et cetera. There's just a lot of variables that go into pricing. My encouragement to anybody that's curious, interested, is to go to your local John Deere dealer and have that conversation. Ultimately, they establish the selling prices and would include whatever, potentially whatever additional costs for labor to install, configure, et cetera, are included. So it would be, it just, whatever number I might give you wouldn't necessarily be accurate. I would just prefer much to just have that conversation with your John Deere dealer.
How difficult is it to mount the sensor hardware to the application equipment?
It's not a real difficult install as long as there is a area where we've got some straight pipe in the plumbing system to be able to put what we call our skateboard or a mounting plate in. That mounting plate is basically shaped kind of like a skateboard where it bellies down into the stream flow, so we get a really good reading across the sensor. Most tankers, that's very easily done because there's usually a long stretch of horizontal pipe across the length of the tanker, or in some cases you saw in the pictures and the video there on the front side of a tanker above the pump. We do require a flow meter to be installed ahead of the sensor to get the flow readings. Dragline equipment, it can be a different story. It can be a challenge on some of the dragline designs that are out there. Some cases, the only piece of straight pipe on the whole rig is the stinger that the dragline attaches to, and we really aren't supporting that install right now because of the vibration impact of that stinger when it turns on corners and turn rows. When it hits the stops, there's usually a pretty sharp impact, and that's detrimental to the sensor. So we prefer to be off of that location. We do work with local manufacturers on the design of these and the mounting, getting them designed to help mount that skateboard in the correct place, getting the correct design on the skateboard so we get the right positioning of the sensor.
The next question is pertaining to a previous question. Does the sensor measure N, P, K separately?
Yes, we document those levels separately. So it's taking that light reflectance back, and it's running it through the different curves for each of those nutrient levels, all at the same time.
Next question. How many producers are utilizing multiple tankers, making outfitting each machine fiscally difficult? Do you have plans for a solution to take samples with stationary kit?
So there's been some work in Europe with a stationary pump or stationary sensor design where they're pumping it out of the location into tanks like that, or if they're sending it into digesters and stuff to be able to monitor that flow. It's definitely something we're looking at over here. The company that's doing it in Europe isn't exporting that one over. So we're looking at what kind of options would there be for over in the U.S. There's some things that, if you're wanting, you don't get with this kind of setup, you don't get your as applied maps. You just basically are getting an average sample reading for what's going by the sensor at the time, which gives you more data than pulling one sample or two out of a pit and sending it to a lab and getting it after the fact, for sure. But there is some drawbacks of not being out on the machine as you're applying it to get that nutrient application map that is beneficial for your other nutrient requirements for the crop.
So really you'd be sacrificing then that as applied data and knowing how many pounds of N, P, or K were actually applied at a given point in the field, so that you might be able to really execute a variable rate nutrient program to hit that total crop nutrient plan.
Right. You'd have documentation of load values going out, but you wouldn't have it as an applied layer where you could actually then execute additional precision ag off of that map.
Next question. Can this work with low TS wastewater applications, less than 2% TS?
That's a good question. No, right now we are between 2 and 10% on our dry matter curves. This low solid wastewater, where we see it in areas where they use a lot of water for flush, or in areas where they're using 2 and 3 stage separation lagoons, there's not a lot of nutrient left in there. That is one of the areas we're working on the curves to get it a little tighter. This is not a common practice over in Europe, so there wasn't a lot of samples pulled initially to create a really good reading there. We did discover that in our validation testing over here, so we're continuing to work on that. There is will be a physical limit in how low we can go based on the technology. The near infrared light reflectance type technology isn't going to be able to analyze it all the way down to the very 1% or 1/10, or whatever it may be, dry matter side of it, where a wet chemistry can actually monitor on down lower than that. So the low dry matter side is one that we're focusing on to get that better accuracy, and to have a definite point there where we can say that at this point and below, that just physically we can't read with this kind of technology.
What's the expected lifespan?
Expected like any electronics, they very rugged. We've run this kind of sensor on our choppers for a number of years. It's running on a spout on a silage chopper. It's subject to vibration and dirt and long hours, and we've got good, expected life out of there. The equipment comes with a 1-year warranty on it right now. It's kind of like any electronics. If there's an issue, it's usually going to show up right away from the manufacturing side of it. Light bulb is probably the thing that we see wears out first on these type of this technology, because it is a halogen light bulb in there that creates that light for the spectra.
I'd say the other piece of that, and you mentioned 1-year warranty, the other thing that we're actually actively working on, don't yet have available, is power guard for the sensor technology to help actually extend that warranty life even longer than the 1-year original purchase warranty.
And this is our last question for the day. Does the sensor have to be calibrated?
Yes, we set an expectation of every 1,000 hours, or at least once a year, do what we call a black and white reference, and that's a calibration of the sensor for total absence of light, which is the black reference, and full on light, which is the white. So when you're looking at reflectance, it's going to fall somewhere in between there. It's a very simple test. Our dealers are able to perform that on the sensor. It can be done in the off season at the dealership. It doesn't have to be on the rig to be able to do that particular test.
Okay. Well, we've come to the conclusion of our webinar. Just a few housekeeping. Anyone who has signed up for the webinar will receive an email with the link for the webinar, so you can view it at your own leisure. Those questions that have not been answered, Chris or John will reach out to you directly to discuss that with you. Thank you for your time, and we appreciate you taking part of the John Deere Harvest 3000 webinar.